Let's move on with the program. Our next speaker is Peter Erasmus, who is CEO of the DirectTech Group. His detailed bio can be found on page 63 of the program. Briefly here, Peter is the CEO of the DirectTech Group of companies, which he founded in 1993. He started his career with a working bursary from Anglo-Val, where he studied electronic systems. He's passionate about South African business opportunities and firmly believes that the only way that South Africa can ensure continued prosperity for its citizens is to ensure the country can compete economically with its neighbors and competitors on an equal footing. Hi, Peter.
Good afternoon, ladies and gentlemen. When I was asked to give a talk at this event, I first of all used my friend Google to find out exactly what advanced manufacturing technologies is and the number of definitions around that, and then also with regards to what SMME actually really means. And we heard from the previous speaker, and we've a lot of information about Industry 4.0, but I went and had a look and just basically looked at the widely used definition of advanced manufacturing technologies. And basically it says it involves the use of technology to improve products and processes for the relevant technology being described as advanced. And then I had a look at another definition. It says advanced manufacturing technologies is a modern method of production incorporating automated and sophisticated computerized design and operational systems. Then the aim of advanced manufacturing technology is to ensure the manufacturing of high quality products at the lowest cost within the shortest possible time. So that sort of covered me what you could, because we deal with these things, we work with them every day, but do we actually really know what the definition's all about? So then I went and had a look at it and said, I must do a talk today on what SMME really is. And it varies from country to country. But in South Africa, SMME would be an enterprise with less than 200 members and less than 74 million rands worth of revenue, which I found quite strange because I would have thought that would have been a bigger organization. So the talk that I was asked to do today is having a look at how advanced manufacturing technologies has enabled our business, and that's what I can really talk about because it's a practical point of view. We have a business and how it's actually enabled our business to produce the products that we produce for our customers, and also how it's actually enabled our customers to grow and prosper. So if we look at it, advanced manufacturing technology is a combination of collective or special tools and processes. But the attitude or approach is important to the tools and the procedures. With the right attitude and or acceptance, the procedures and the tools will have little benefit going forward. So then I looked at it and we said when we started the company in 1993 and, from a one-person company, today we've got almost 120 people, we said, why were we successful? And we did an analysis and we said, well, the main reason that we were successful was really attitude. We had all the barriers of entry when starting a new organization. No one knows you, you don't know very much, you have the financial burdens, everything else of that nature, and those all affect your, possibility for success. And then we put it down to a logo which we carry in the company today, which is impossible is an opinion. And it's a logo which the guys talk about in the company. They say, but why have we got this logo? And because we're asked to do so many different things, and a lot of the times, we say, oh, it's impossible to do it in that time, or it's impossible to do it here because no one else has done it before. So we have you've got to have a can-do attitude, and we look for reasons to succeed rather than reasons not to succeed. And one of the other sayings that I learned from a colleague when I was just starting out, he said to me, somebody has to do it, might as well be us. And I thought that was a real good, saying to take on. So besides the tools and processes which advanced manufacturing technologies offer us, okay, one of the most important enablers is people. And if we empower our members to achieve, then we'll be successful. So how do we empower our members to achieve? We need to empower them to say that you will be successful and that and that you're not going to fail. Because so many people look at it and they say, well, I've never done it before, therefore I can't do it. And if we adopted that philosophy, none of us would still be crawling instead of walking today. So when I was discussing with our team members and I was discussing coming and doing this little talk today, one of our team members made a comment and he said to us, direct tech years are like dog years. And I said, what do you mean by that? He says, no, we need to achieve 7 years in 1 year. So he was saying that in 1 year, you'll get 7 years experience because of all the different things that we actually do. So in going forward, in the background, there are just some slides that are running of different, projects and challenges that we've actually had with the customers and problems to sort out. So defining direct tech, what is direct tech and how did direct tech use the advanced manufacturing technologies to achieve what it did. So defining was very difficult because we do so many different things, but we could be identified as a solution provider, which is probably the closest one, but that's also so vague that you could put it down to so many different things. We could be classified as an EPC, an engineering procurement company, or a machine builder, or a system integrator, or a company just providing advanced manufacturing technologies. But in a nutshell, we provide a solution. So how does in all opportunities really start normally with somebody having a problem. So if we look at the types of work that we actually do, we start with a customer that approaches us and he's got a particular problem. He wants to produce maybe 1,000 widgets an hour. He wants to have a machine capability of 99.8% and an overall operating efficiency of say 65%. And he's got maybe R1 million to spend on the machine, and he wants to have it built in 2 weeks. So that's basically where we actually start with the project. And then we've got to sit with the customer. He knows what he wants, but he doesn't know how to achieve it. So we sit down and we say, put in all these things together, and now is where we actually start using the advanced manufacturing tools to actually get to that particular position. So in today's world, we're very, very lucky. When we first started off, there weren't such nice CAD packages around, but today with the 3D modeling and everything, so we normally start off with a good CAD package, and we create a model of the plant or the piece of equipment that the customer is actually looking for. And from that model, we can interact a lot with the client, and so we can get most of the design features and restraints and dimension restraints and everything sorted out. And then basically we can move to the other areas when we start moving to the manufacturer and we start using some more advanced manufacturing tools, like things with laser cutting, CNC machining, bending, welding, and the rest of the processes with painting, powder coating, and we end up with an assembly. So all of these processes basically we run through with the customer. So the opportunity that we have is that it's born by the customer's need, and I feel that that's a lot of us are looking to try and create a technology as opposed to basically have a look what the customer's actual need is and then basically provide the technology. So in our experiences, we work a lot with some of the predominant OEMs, companies like esteemed companies like BMW and Toyota. They have very different ways of doing things. Some embrace a lot of electronic type reporting systems, and other guys basically use simple pieces of paper. And all of these they all tie into advanced manufacturing technologies, even a simple piece of paper that can actually be recorded and can be put into a data spreadsheet later on. So a lot of the technologies are there, but I don't think they're collated properly later on. So I'm going to talk about just some of the projects and really how they started, and just to show you the typical process that would actually go through and the types of technology that was delivered out of it. We did a project, and it would be on the videos. It would have been called for ZF Limferder. And ZF Limferder, they manufacture axles, front axles and rear axles for BMW. And we had a project with them that we did in 2003. And they were looking at a new assembly line because BMW were going to build a new range of motor cars, the 3 Series. And so they had a budget to actually produce a new assembly line. And in the assembly line, what they wanted to do is they wanted to have normal, standard, conventional conveyor technology, which would advance the workpiece from station to station. But their building was a long, thin building, and basically if you put a conveyor right down the middle of the building was cut in half, which would create a lot of different problems for logistics, getting the components to the different assembly line. So being one of the proactive suppliers that were basically looking to provide a solution to the customer, we suggested, why don't they look at automated guided vehicles? So at that time in 2003, AGVs were not very well known in South Africa, and the customer was originally said, well, that sort of technology we have to buy out, and we said, no, we can actually develop that technology here in South Africa. And we then presented them with a CAD model or solution of what it would actually look like and how their line would actually be. And then they, how can you say, liked the idea because it would get rid of a whole lot of the logistic issues. And they said, okay, but can we afford to do it? And we said, well, we can afford to do it. And they said, has it ever been done in South Africa? And we said, no, we haven't done it. We haven't done it in South Africa, but that doesn't mean that it can't be done. So then the next step came and said, well, this is the budget that we've got to do it. Can you do it for that particular budget? We said, yes, we can do it. And the next step was to go to Germany and to Europe and go and have a look at the latest technologies in the plants to make sure that they were going to get something similar to what the guys were using in the plants that were producing 800 units a day. At that time, BMW was going to produce about 300 units a day. So, and that's how we started. So when we went there, our AGVs that we initially proposed were going to be battery-powered AGVs. When we got there, they said everybody uses induction transfer technology. We came back and they said, well, the advantage of induction transfer technology is that the power is always going to be there, but it's an expensive technology. So once again, we said, well, can it be done locally? So after a man year of, struggling, generating lots of ozone, and making the component suppliers, electronic component suppliers quite wealthy with the components that we actually blew up, we actually managed to get the technology going, and that technology is still in and running, after 15 years. It'll be removed at the end of this year when they put in a new line. So it goes, and all those AGVs were all almost, you can say, at that particular point in time, Industry 4.0 compliant. They all had wireless connectivity as they were running around the cell. They connected to a SCADA system. They reported the data back. They reported the processes that were operating on them, and everything back in 2003 already. So these are the what you could. So if we have a look at it, we used the advanced production methods ourselves to actually produce the product, but we enabled our customer to create a production line where it's achieved the aims of advanced manufacturing technology. And that is basically to ensure ensure that you can produce the highest quality product with the lowest cost within the shortest possible time. So then we can have a look at another sort of case study that we did for BMW just recently. And, you know, everybody, all manufacturers today look at how they can achieve the aims of advanced manufacturing technology, and that's basically the highest quality product, the lowest cost possible price within the short possible time. And they looked at AGVs for logistic delivery to the assembly line. So on the assembly line, because of all the different model variations and having to store so many different types of components, you know, just for, you could have 5 or 6 different steering wheels just to build one model motor car. And so line side real estate is very, very, how can you say, sought after, and it's in short supply because of the size of the lines. You can't just make the plant longer and longer because that creates more logistic issues. So BMW said, well, they know what they wanted. They determined the price that if they rolled out this technology that would work for them, but they didn't have a company to provide that. So they went out to industry and they said, okay, well, you know, this is more or less what we want, guys. You know, this is more or less what we want to pay for it, okay? Can you come up with a solution for us and for that particular area? So we got an order for them to produce the first prototype AGV. And in that AGV, we wanted all the nice things like Industry 4.0. It had to be a peer-to-peer communication on all the AGVs. We want to monitor things like the current usage, the VO, the batteries, because they're all battery-powered and all that sort of stuff. And they want to be able to have it report to the IPST, which is the central reporting system. So it had to be fully compliant with Industry 4.0. And they said, okay, well, here's the first order, make the prototype. And we said to them, okay, but we can't. You understand you want to make the price lower because otherwise your business model doesn't work. We said, we can do that, but then you've also got to move away from some of your standards, because in the big OEMs and these guys, they've always got standards they don't want to deviate from for repairs and spares and that type of thing. So we said about that. So we developed the first one. They liked it and took us about, the turnaround on that was about 3 months. And then we rolled out the rest of the systems, and now they basically got them in production runs and that type of thing. So the enhancement is that the benefit for the customer is that he's got a technology which is locally supported. It's doing exactly what he wants it to do. It's at the right price for him, okay? And now they basically need to roll the technology out further into the plant. So basically the rest is up to them. And these are the types of project and the types of industry that we can do going forward. You know, there's a number of different examples that we've got. Those are those are 2 motor industry related examples. We work completely in other areas as well. We had a customer that had a water business, and in his water business, you would say, well, how much technology can you put into a water business? We all know that the automotive guys are very, how can you say, proactive and using the latest technology. So you can cross the different technologies from industry to industry. So we said, okay, we started with a company. The company was called Aquazania, and they wanted somebody to design how can you say, a filling and handling system for them. But it all started with, you know, that had to go right down to the vehicle. So there were a whole lot of problems associated with making sure that these 22 or 5 US gallon 22 liters or 5 US gallon bottle water, you know, that you could actually handle them. You know, then they have different properties when they're heavy and when they're full, and different properties when they're light. So we had to design a stillage or what we refer to as a stillage or a rack to basically carry these particular bottles. And that was the first part of the problem, because that was the interface, and the interface was either a person loading them or a machine loading them. But once we got past that, and that was quite a lot of R&D to basically tick all the customers' requirements there, we then set about having a look at how we can actually automatically replace the stillages. So the stillages come in, there'd be 32 places in it for 32 bottles, and we had basically, the robot system took out the the empties and replace them with full water bottles, and then they would go out again. And so and we used a robot there because, once again, if you look at the handling capability of, having to do 822 kilogram bottles a day, it's not something that you want a human to do. So it was an ideal application to do that. So, and we rolled out with that type of technology. You can master the reporting. You can see exactly what's actually coming in, what's going out. All of that is actually built in between the robot and the PLC controllers and the SCADA system that actually sat on top of it. And it was a very, very small supplier. He's now actually quite a big company, and they've done very, very well. And so what we did was we said, well, with using some advanced manufacturing technology, we were able to, how can you say, enhance our business and enhance his business so that he could go to the next level. So, some of the other opportunities are not just maybe related to technology, but related to time as well. There's also an opportunity there. So with the use of advanced manufacturing technologies, basically being tools and or procedures, you can deliver systems very, very quickly where others can't, and that will basically give you a competitive edge. We had a project which we did for Toyota, and they had a conveying system where they had lots of rust problems basically down in the coast, and they wanted to change that to stainless steel. But we had only 40 days to do the complete project from start to finish, from design to scratch, to design to factory test, and then to travel to site and to implementation. So the advantage that if you've got good manufacturing technology, if you've got good manufacturing systems, you would be able to implement. If you didn't have that, you wouldn't have been able to execute the project. And the benefit for us was, yes, we got a project to do. The benefit for the customer was he got everything done in his time schedule for his reasons that he wanted to do. So that's pretty much the end of my little talk, really, about advanced manufacturing technologies and the benefits that we found for our little company and also for our customers, and the types of benefits that can be derived from it. When we first started, somebody once said to me, the most important thing about management is measurement. You need to be able to measure before you can manage, otherwise you're just guessing. And with advanced manufacturing technology and technologies such as Industry 4.0, it basically gives you all that information. But once again, the information is there, the systems are there, the tools are there, but if you use it, it has benefit. If you don't use it, it will have no benefit and just add cost. Thank you very much. Thank you.